This page is for lesson 5.4 in your notes where we talk about factoring. We spent so much time on this at the beginning of our chapter before we even started the lessons, so this is just a quick brief overview to remind us of what we learned. First off, a couple of things. We said that when you factor something, that is to break it down into its smallest pieces. Break it down into its smallest pieces. So for example, if we talk about the number 24, you could break down 24 into 12 and 2, but then you can also break up the 12 even further. So you could break this up into 2 times 6 times 2, but then also remember the 6 could break up even further. So we'd say 2 times 2 times 3 times 2. That would be the factored form for 24. When we're dealing with equations, factoring, breaking it down to its smallest pieces, means that our answers will look like parentheses, parentheses. Maybe there's something sitting out in front even, like a GCF, a greatest common factor, but you will at least have a parentheses and a parentheses as your answer. We also talked about how factoring is the opposite or the inverse of foiling. Inverse of foiling. How these two go backwards and forwards. And we said foiling we know is multiplication. So if this is the inverse of multiplication, factoring must mean division. Okay, so that's our quick reminder of what we talked about for factoring. Factoring is division and breaking it down into its smallest pieces. So let's look at just a couple examples here. There were two methods we talked about. One was the MAC method, the other was guess and check. So I'm going to show the MAC method just because some people really like to have the step-by-step for that, and then I will also briefly talk about the guess and check for those of you who like that one. First thing that you always want to do is check for a GCF. So in our first one here, we actually do have a GCF of 3. We're going to pull that out, so we get 3 parentheses x squared minus 8x minus 9. That means our final answer is going to have a 3 sitting out in front of these two parentheses. So don't forget him. He should show up at the end. That also means that when we run MAC, we're only running MAC on this inside piece. So when we make our MAC chart here, M and A, remember you multiply the first term by the second term, so 1 times 9 is 9, and then you take the middle term, which is negative 8. We need two numbers that multiply to be positive 9 but add up to negative 8. Excuse me, that is a negative 9 there. So multiply to negative 9, add up to negative 8. You can try a couple different things, but you should come up with negative 9 times 1 multiplies to 9 and adds to 8. Negative 8. So those are the two numbers we're going to use. We're going to go ahead and say x squared minus 9x plus 1x minus 9. Again, only dealing with that inside part right now. We know that 3 is going to come back later. Notice that we took these two numbers and they replaced the middle term. That's what's happening here. We then go ahead and split it in half, and we look at the left-hand side and say, what is common? We can pull out an x, so we're left with x minus 9. On the right-hand side, it doesn't look like anything's common. So if there's nothing that looks like it's common, that means we can pull out a positive 1. And if we pull out a positive 1, it's just itself, meaning that our final answer here should be x minus 9, and then collect these pieces, x plus 1. And again, that 3 has been waiting the whole time in front of everything, so he's still here. So that would be our final answer, is 3 times x minus 9, x plus 1. Now for those of us who like the guess and check method for this one, we rewrite it, 3, and then we knew that we factored that out to get x squared minus 8x minus 9. Even with guess and check, you're still going to pull out that GCF of 3 and then just deal with the inside pieces. First of all, you look at your first term here, and since it's simply an x squared, we know that we will have an x and an x in the front. X times x is x squared. For the back, we know we have some options. We know it could be negative 3 and 3 for 9. We also know it could be a negative 9 and a 1. So we're just going to try a couple. We talked about how usually you try the closer numbers first. So we're going to try negative 3 and positive 3 here. And then we see that x times 3 would give us 3x, And then negative 3 times x would give us negative 3x. And 3x and negative 3x would cancel. That's not good. We want negative 8x. So it can't be these ones. So we're going to try instead the next pair of numbers here, which is the negative 9 and the 1. So we'll try negative 9 and we'll try 1. X times 1 is 1x. Negative 9 times x is negative 9x. 1x plus negative 9x, that would be negative 8x. So that's our final answer. And that's our guess and check method. It should be the same answer that you get using your MAC method. Again, I don't care which method you use, you just have to be able to get the correct answer. All right, second example here. Example 2. Using our MAC method, first of all, check to see for a GCF. Sure enough, we see a GCF of 2, so pull that out. So we'll have 2x squared minus 11x plus 5. And then when we run our MAC chart, we want the 2 times the 5, so that's 10, and then negative 11 for the A. We're looking for two numbers that multiply to positive 10 and add to negative 11. So we could do 1 times 10, that's positive 11. So if we want negative, let's do negative 1, negative 10. Two negatives equal a positive when multiplying. And then adding them together would give us the negative 11. So that's what we're going to want to use here, are these two numbers. Again, they will replace this middle term. So we will leave this 2 out in front. Remember, he comes back later. And we will say 2x squared minus 1x minus 10x plus 5. That's these pieces in here. We then cut it in half and look for what's common on the left-hand side. Right now I just see an x, so we get 2x minus 1. And then over here, what's common looks like a 2. Notice how this is a negative 10, so you want to pull out a negative 2 here. Negative 2 times... Oh, actually, I'm sorry, it's not 2, is it? 10 and 5. We want to pull out, it would be a 5 that'd be common. There we go. So negative 5 times 2x, negative 5 times, it'd have to be a negative 1 here. And again, that's all going on while the GCF sits out in front. And so we will say 2x minus 1, collect the leftover pieces, x minus 5, and our GCF, who's been here the whole time, he just sits out in front. So that is our final factored answer. It's been broken down into its smallest pieces. All right, let's talk about the guess and check method. Guess and check method, same thing. We would still want to pull out that 2 for the GCF. So we'd say 2 times 2x squared minus 11x plus 5. So our final answer will have a 2 out here, and then we'll have some parentheses. And then we're just going to try to check some different things. We see that this is a 2x squared in front, so we know that we have to have a 2x and an x. 2x times x is 2x squared. This one's nice. There's no options here. It has to be 5 and 1 for the back. So we just try a 5. We try a 1. We look at the signs. We say that it's a positive in the back, which remember, if it's positive, the signs must be the same sign. And since this is a negative 11, we know that they must be both negatives in here. So we check it really quick. 2x times negative 1 is negative 2x. Negative 5 times x is negative 5x. Negative 2x plus negative 5x, negative 7x. That is not our middle term, so can't be those. We will then try switching the numbers and try putting 1 and 5. And again, when we check it, 2x times 5 is 10x, and it's a negative 5, so negative 10x. Negative 1 times x is negative 1x. That would be negative 11. So there's our answer. All right. So hopefully we're getting the hang of that. If you need more help with those, please ask me after school quickly, because we do need to use this in the upcoming lesson. The other type of factoring that we want to remind ourselves of is sometimes we see problems which have a term in the front that is a perfect square and a term in the back that is a perfect square, and they are separated by a minus sign. And if you remember, this is what we call our difference of perfect squares. You might remember an easier example, something like this. If we have, say, x squared minus 25, remember we said that it's x plus 5 and x minus 5, the only difference being the signs here. And again, if you think about foiling this, your x times your x would give you x squared. Positive 5 times negative 5 is negative 25, and these middle terms, 5x and negative 5x, these cancel, which is why there is no middle term in there. That's that difference of perfect squares. It means the number in front is something perfectly squared and the number in back is perfectly squared. Super important that they are always separated by a minus. If you ever see x squared plus 25, we say it is prime, meaning there is no way to factor it. It can't be broken down any further. That's as far as it goes. So for this problem right here, let's go ahead and let's do this down here. 9x squared minus 144y squared. You're going to have two parentheses. You're going to take the square root of the things in the front. So 9x squared, you're going to have a 3x and a 3x to get that first term. The last one, 144y squared, would be 12y and 12y. And then the signs, 1 plus and 1 minus. And that's our difference of perfect squares option.